the synthesis, right? So how do we make amides? Well, there are several routes, right? So that were devised. So it turns out we can start with some sort of acid chloride, right? So maybe let's show like a random acid chloride, which is going to be looking like this, right? So a little bit of the review time, by the way. So then we are going to react it with an amine, right? So we can use a secondary or a primary amine. So the point is going to be kind of like similar across the board, secondary, primary amines. What's going to happen is that you are going to chip away the H, one H from the primary or secondary amine, and then you will make the CN bond, which we will just take a look at in just a second. Let's imagine we have like here diethyl amine, right? So two ethyls on the nitrogen, so and the amino group right here, right? NH in this case. So what's going to happen is that we are going to circle away chlorine and H, right? So they will form, guess what? HCl, right? So we have our reaction arrow, will form HCl as a byproduct. It's an inorganic molecule, right? We're not quite interested in that, in this chemical transformation. We are mostly after the organic chemistry substrates, right? CN bond will be formed. So that's electron, electron, which are liberated upon the breakage of the bonds. Finally, time to show the squiggles here. And we have our N with the dot, ethyl, ethyl. Don't forget the parts which don't participate in the chemical reaction. They still carry over, right? So don't just kind of like say, well, if they don't participate, then we might as well skip drawing them, right? No, 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 that's not the case. So here we go. CN bond will be formed. And now you are going to have your amide situation, right? Carbonyl with N, and then N in this case with a couple alkyl chains. So yeah, maybe if we had like NH3, we could obtain something different, right? So maybe it's going to be like this, right? So no problem. So if you just reacted with an ammonia, right? So then you are going to have here NH2 instead of NH3. So maybe if you reacted with, let's imagine there is like some sort of like long chain here, right? 1, 2, 3, 4. So butyl, right? Okay, well, no problem. So like 1H will be away, 1H will stay, right? So, and then here we go, right? This H stays, okay, here that one, here that one. And then we have four carbons, right? One, two, three, four. So four carbons. So this one stays as well. So that's it. That's your like a synthesis of the amides. So then what else can we do? We can also use anhydrides to make amides. So let's draw them. What's going to happen is the following, right? So we're going to have some sort of anhydride. Let's imagine that we're going to have an anhydride like that. Oops, sorry, that's an oxygen here, oxygen. So this is our target, right? Or these are our products, right? So it turns out that we'll just circle the almost acidic part, right? The almost acidic part. And then here we have the H. Now together they will make an acid, right? So HO, so O and H are connected. H and O are connected. Now they form the bond, right? Guess what? And then you are going to have your acid, right? So propanoic acid under these circumstances. And then you will have the amide, right? So let's just show the compound here. So CH3, CH2CO. And then you're making CN bond, right? With all the leftover features, such as those great alkyl chains. So that's your amide, right? So that you formed from your anhydride. So now more, right? So chemical properties, right? So we looked at the synthesis. Now we want to look at like what else can amides do, right? So amides can hydrolyze, right, under acidic or basic conditions. So let's take a look at some examples, right? So here we have like, let's say ethyl attached to the carbonyl, then we have our amide. Let's imagine that amide is going to be looking like that. Couple methyls here, right? So now we are going to hydrolyze it using the water. So HOH for our educational purposes. Typically, the hydrolysis is carried out in acidic conditions. We can use HCl specifically as a catalyst here. And then we're going to circle what's gonna be making an amine, right? So the amine will be made, right? So because if you think about that, so we used the amine and, for example, acid chloride to make the amide, right? So we are kind of going back to more or less like the same compounds, right? So, except here you're going to make your NH bond, right? So you made an amine, okay? And instead of the acid chloride, yeah, you are going, turns out, to make the acid, right? That's how this reaction like decided to behave, basically. So nature gave it to us. So then we are grateful for this. So we have the C with an electron and oxygen with an electron, which will form a bond, and you have your OH bond, right? Don't forget the things that don't participate in the chemical reaction directly, they still kind of like stay, right? So um, yeah, so that's like what we need to keep in mind. So like things or this guy, right? So like CH3, CH2 didn't participate directly in the chemical reaction, but it still carries over. So like don't forget to like redraw those things. Let's now take a look at another type of hydrolysis of amides, which is basic hydrolysis, right? So here the situation will be a little bit different, right? So, but the result will be kind of like similar. So anyway, we have here the heat, right? So we need to apply some heat to carry out the basic hydrolysis. And of course, we need to have the base, right? So we'll have here, let's say maybe potassium hydroxide, KOH, right? And our amide, right? So what's going to take place, you may ask. All right, so I'll tell you what. So we are going to form the salt of the carboxylic acid, and we're going to form the amine, right? So yeah, basically, for our like simplification purposes, we are going to circle the things which will be connected, right? So this is going to be this like N with the dot and standing for an electron, and hydrogen can also be theoretically having the dot, right? So which will be connected with the dot on the nitrogen to make an H bond and the amine as a result. Let's show it. That's them, methyl, methyl. Okay, great. So that's your amine that you just made. And then the salt, well, so it's close, right? So you have this dot on the oxygen and dot on the carbon. So let's connect the dots, right? Pun intended, and see what's going to happen, right? So you have O. Okay, my initials, by the way. So very good. So now you made nothing more than the salt, right, of the respective acid. It was the what it is potassium. One, two, three. Potassium propanoate, by the way, right? So the like potassium salt of propanoic acid is going to be obtained as a result of this base-assisted hydrolysis of an amide, right? So, and then here we go, the exciting chemical properties of amides.